Hello again. Welcome back to geometry. Tonight we're going to talk about some angle relationships in circles. So we've been talking about circles. We've been talking about secants and tangents and chords and all that kind of good stuff. Tonight we're going to talk about what happens when you have those different segments and lines all intersecting. What happens to the angles with regards to the circle. So we're going to start off with a theorem, the tangent-secant theorem. This one just simply says that if we have a tangent, you can see it right here, this tangent, line BC is tangent, and a secant, that would be line AB, intersecting on the circle, so you can see right there B, they intersect, then the angle they form, angle ABC, is half the measure of its intercepted arc. So half of the measure of the arc that's inside that angle. So if you look, that would mean that angle ABC has to be half of whatever arc AB is, because that's the arc that's inside or intercepted by that angle. So just the measure of angle ABC equals half the measure of arc AB. Alright, next theorem. I call this one the two-secant or chord theorem. And that's because it has to do with two secants or chords intersecting. Specifically, if you have an angle like angle 1 is labeled here, formed by two secants or chords that are intersecting inside the circle. So you can see here, we have these two chords, AD and BC, and they're intersecting right here at E, that is inside the circle. Then its measure, they measure that angle, is the average of its intercepted arc and the intercepted arc of its vertical angle. So if you look at measure of angle AEB right there, angle 1, angle AEB, it says that its measure, so how many degrees that is the average of its intercepted arc, so that means arc AB, and the intercepted arc of its vertical angle, so arc CD. So all I did is I took AB, added it to CD, and then divided by 2, because that's how you find the average. So arc AB plus arc CD divided by 2 will give you these two vertical angles here, angle AEB and angle CED. Since we all know vertical angles are congruent. Alright, so one more. This one's got three parts to it. So I know there's a lot on the screen right now. If you look, I'm going to try to explain this into three different pieces. So if we have an angle that is formed by two secants, so if you look here in this first example, we can see we have two secants. Line LJ and line LN are both secants. They're going straight through the circle. And you can see angle L is formed by those two secants, intersecting outside the circle. So being outside is really important on this. Then the angle L, is equal to half the difference of its intercepted arc. So what we're going to do, instead of on the last one, where we added the arcs and divided by 2, this time I'm going to subtract them. So I'm going to take this JN, the bigger arc that it intercepts, subtract KM, the smaller arc it intercepts, and then divide that answer by 2. So take the two arcs, subtract them, and divide by 2. And that works if it's two secants that are intersecting, two tangents that are intersecting, or a secant and a tangent that are intersecting. The real trick to this is that anytime you have any combination of those lines intersecting outside your circle, so like here at L, or here at F, or here at C, the intersection is outside the circle, then this theorem is going to work. You're going to end up taking the two intercepted arcs, subtracting them, and dividing by 2. And that'll get you your angle measure. So let's do a couple of examples. The first one we're going to do is from that first theorem, that tangent-secant theorem. And you can see we have a couple of tangent-secant intersections going on. We have angle SRQ right here, which is 71 degrees, and angle STU right here, which we don't know. So let's deal with the SRQ first. We know that SRQ has to be half of its intercepted arc, so SR, well, if SRQ is 71, 71 has to be half of whatever SR is, so just double it, and so we get 142 for SR. On the other side, I know the arc, ST, and that has to be twice as much as angle STU is, So I'm just going to take the ST and divide it in half. So I know that half of measure of arc ST is 83 degrees. That means angle STU is 83 degrees. Okay, so that's the first theorem. Second theorem. Notice here I have, once again, two chords intersecting in the middle. I don't have any of these angles, but I do have a couple of my arcs. Not all of them, but two of them, which lets me say, all right, those are intercepted arcs of vertical angles. So I should be able to find the measure of angle MNQ and the measure of angle RNP, because they should be the same. And the way we're going to do that is they should be the average of their intercepted arcs. So I'm going to take that 91 and that 225, add them up and divide by 2. 91 and 225 is 316. Divide that by 2, I get 158. So that means the average of those two gives me 158, and that'll be these two angles right here, my vertical angles. And that was my 2 secant or chord theorem. Last one, example number 3. On this one, you can see we got this intersection outside the circle. Remember, outside the circle was key on this. If it's outside the circle, then we're going to have to do this half the difference formula. So I take my two arcs, I have 83 and x, I'm going to subtract them, 83 minus x, divide by 2, and that should give me my angle, which is 25. So just kind of plug it all into my formula here. 25 equals 83 minus x divided by 2. Start applying some algebra. Again, I multiply both sides by 2 because I'm dividing by 2, and that's the opposite. So I get 50 is 83 minus x. I'm going to go ahead and subtract that 83 from both sides with the x by itself. I get negative 33 equals negative x. Since they're both negatives, I'm going to divide both sides by negative 1, or just basically get rid of the negatives. And I get x is 33. So I end up with a 33-degree arc right there, which, if you look, 83 minus 33 is 50, divided by 2 is 25, so that does work. That's it for tonight. Remember to make sure that when you're taking these notes, that you're doing it in the 2-column format that we talked about in class. And I will see you guys on Monday.